So we are looking at 9.4 Part 1 notes, and we are doing notation for function operations. So I need you to understand that everything we're doing with these operations, it's old news, and function notation's old news. So I'm reminding you that this stands for f of x. Doesn't that mean the function of x? And so we're coming back to domain restriction, we're coming back to function notation. And we're also going back to chapter 6, where you're going to add two functions together, subtract, multiply, divide. We did all of that in chapter 6. Do you remember that we named things? Remember we named the degree and the type of polynomial? Okay, the degrees were constant for degree of 0. What was degree of 1? Linear degree of 2? Quadratic degree of 3? Cubic? Ooh, only one on that one. Degree of 4? Quartic. Degree of 5? Quintic. And then we would name the number of terms, right? Monomial, binomial, and everything past 3 was a polynomial. So we're really doing the same thing, but instead of me giving you the problem, I'm giving you function notation like this: f plus g of x. So you're going to have two functions, the function f, the function g, both based on the variable x. That's all that's saying. It is not times x. The function f plus the function g of x. Now, this translates to saying the same as taking the function f of x plus the function g of x. So the function notation for the operation can be shown to sort of compound, or it can be shown to where it's two separate functions together. All right, subtraction, it looks the same. Function f minus the function g of x. And that is the same as f of x minus g of x. All right, multiplication, it will be like this: fg and then of x. So they don't even show the multiplication symbol. It's understood. Remember, the f and g are not variables. They're defining your function. That is the same as saying f of x times g of x. Now, be careful here, because the next lesson we're going to do is going to be compositions, and that's an open circle. So that's a time symbol. Division, f divided by g of x, is the same as taking the function f of x over the function g of x. Now, you also need to be careful with division. Means you're going to have something in the denominator, right? So we would also define that the function g of x cannot be 0. Why can't the function g of x be equal to 0? Well, I think I heard it. It's undefined because it's a domain restriction, right? The order does matter with subtraction and division. So don't be fooled if they tell you to find g of x minus f of x. You have to think about the order too, okay? All right, that's it. So here's what, let's not make it any harder than it is. Here's what we have. We have f of x plus g of x. So if you want to rewrite it, that's saying take f of x plus g of x. That's all it's telling you to do. Now here's what I'm asking you to do. In your notes today, show this, because I want you to be comfortable however they give it to you. You are literally going to put parentheses here and drop f of x in there plus g of x. Now, do I always need parentheses? No. But if we always use parentheses, we'll have them when we need them. Okay, so what is the function f of x? 4x squared plus 3x minus 1. So that is f of x. I just drop it in. What is the function g of x? 6x plus 2. And then I'm just going to add like terms. So some of you are going to say, well, I didn't need parentheses. Yep, there's nothing to distribute. We're just going to go through and add like terms. So we would have 4x squared, then what? Plus 9x, then what? Plus 1. Now, if you're given a problem in function notation, then you should give the answer back in function notation. So you have a delta math. Delta math only wants you to give the answer, not function notation. I actually didn't try it with the function notation. It just, the answer is all they gave, okay? But for me, if you're doing a graded worksheet or a quiz or a test, you would then say, hey, I found f plus g of x. You need to define what your answer came from. And that's always been a rule. If you get something in function notation, you give it back in function notation. Got it? And you could write it like this or like this. Okay, now I have subtraction. So this would break down to be f of x minus g of x. This is where parentheses are really important. So you would take f of x minus g of x. So by prepping this, I'm less likely to miss something. I lost my function f of x. Drop f of x in first, 4x squared plus 3x minus 1, and drop g of x in, which is 6x plus 2. Okay, why am I pushing the parentheses here? We do need to change the signs. And I know that you don't have to, but it's really easy. Okay, got a 4x squared, 3x minus 6x, and then a lot of people would do negative 1 and 2 because you forgot to subtract. So when I go to change the signs and I do this, why did I just get it wrong? And I see that all the time. We forget to change that first sign. I think because this is out here, I don't know. But both signs need change. It's like you're distributing by negative 1. Okay, now I don't have to worry about subtraction. So just add like terms. What do we get? 4x squared minus 3x minus 3. So that is the answer for Delta Math. What is your answer for me? F minus g of x equals this. Okay, there are 2 for you to try. So you try. All right, so I'm going to rewrite this to show that it's the function f of x plus the function g of x. So I'm sort of expanding that. And then I'm using parentheses, and I like to just prep it and then come back and drop f of x in and drop g of x in. Okay, when I go to add like terms, I do want it in standard form, right? So the highest degree out of all these, since there's nothing to distribute, is x squared. But when I went to put the 5x and negative 5x together, they cancel, and so did the constant. So my answer is just x squared. So f plus g of x equals x squared. All right, next one. I'm subtracting, so I want to expand this. So f of x minus g of x. I can't stress enough, x is the variable everything's based on. F and g are just function notation. They're not variables. So this is the one where you really do need the parentheses. And 5x minus 6 comes in here. And then x squared minus 5x plus 6. Okay, so let's talk about this. Let me use pencil because I'm going to make a mistake here. So when I go to change this sign, what mistake did I make? I did not make x squared negative. There's actually another mistake. And I see it all the time. I think we're so used to like plus a negative, plus a negative. When you went to distribute the sign, you made it plus a negative. It was a minus 5x. It's still a negative. So be really careful. I just feel like it's just a real quick thing that happens with people. Oh, pencil smears. Okay, now I'm correct, right? All right, what is the highest degree? X squared. So negative x squared, then what? These should add up to 10x, and these should add up to negative 6. Or no, negative 12. You're right. I heard you, and I wrote it wrong. Okay, I just wrote what I wanted. Is this better? Okay, fabulous. What would be your function notation? F minus g of x. Okay, now let's just talk about one more thing here. This was getting people yesterday, and I don't know why this habit started. Yesterday when we were working on things and you guys had to factor, a lot of people know like, oh, she always says to change the sign. And people were just going through and doing this and then factoring. Okay, now I'm not saying this factors or anything like that. Do you understand why I can't do this? I can't just come through and change the signs unless it's equal to something that I can change on both sides. If you do it to one side, you do it to the other. So this whole thing doesn't work for me unless you came out here and put your negative sign out there. So I always say, this is fine. I'm not asking you to factor it, do anything else, so leave it alone. But if you were doing something where you had to factor and cancel, factor out the negative 1, but it can't disappear. You cannot just change the signs. And a lot of people were doing that yesterday. All right, next, multiplication and division. So do you see why I said you've already done this? We've already done function notation this year, and we've already done all of these operations, okay? So when we talk about multiplication, we have f times g of x. That is the same as f of x times g of x. So drop f of x in here, drop g of x in here. 6x squared minus x minus 12, and then I have 2x minus 3. Now, if you look for help in Delta Math, they're going to show you with the blocks. Remember I showed you that, where you can make the block like a multiplication table instead of doing the distribution? Delta Math shows it this way, where they put the 6x squared negative x negative 12 here, 2x and negative 3 here. Remember I showed you could do this? And then you'd say, hey, this is 12x to the third. This is negative 18x squared. If you like that, that's fine. Then pull your like terms, put it in standard form. That's what you'll see in Delta Math. I like to distribute, but here's what I'm going to do. I don't like to take 3 things times 2. I want to take these 2 things and distribute. So I'm reversing my distribution. So I'm going to take a minute and slow my brain down. 2 times 6 is 12. Keep the x, add the powers. I get a negative this time, 2x squared. So think about your sign, your number, then your power. And then 2x times negative 12, negative 24x. All right, what am I going to go back to do now? I'm going to distribute by negative 3. Now, if you did it differently, that's okay. We'll get all the same pieces, and then we'll put it together. So I get negative 18x squared, just like you did in that little note card. And then I would get a positive 3x, bless you, and a positive 36. Okay, now that it's distributed, I'm just adding like terms. Highest power, 12x to the third. Then what? Negative 20x squared. Then my x to the first, minus 21x, and then what? Yeah, and that's considered my constant, the plus 36. Okay, final answer, function notation, f times g of x. There you go. Okay, now we have division. Again, the order of division matters. So f of x has to go on the top, g of x has to go on the bottom. Sometimes division's super simple. You write it and you're done. Sometimes we have to factor and cancel. Depends on if the problem's factor. All right, so are we good there? That's all I did. Guys, you've had how many problems like this? The difference is I did not give you this problem. I gave you the notation and you had to build the problem. That's it. That's the only add-on to this lesson. Does this factor and cancel? You're going to have to do a little trial and error, aren't you? So the first thing you want to look for is that GCF, and there's not one. So I'm going to jump in here, and here's how I'm going to think about this. This 6 breaks down to 2 and 3 or 1 and 6, and I'm hoping it's the 2 and the 3, because if so, then I have a common factor, but maybe not. What are my options for negative 12? Negative 2 and 6, negative 3 and 4, negative 1 and 12. Now, I don't know which one's negative, but here's my thought. I don't even have to try 2 and 6. Why? Yeah, there's a 2 here, and both 2 and 6 have a common factor with the 2, so I can't use them. If I do 3 and 4, what has to go here? The 3, the 4 can't. So I'm going to try it. My first and last work, I'm looking for my outside and inside. So 8x and negative 9x, there's my negative 1x. Okay, does something cancel? What is my answer in function notation? F divided by g of x equals 3x plus 4. You are missing part of your answer. What are you missing? The what? Domain restriction, right? Okay, as soon as you see a fraction, and the domain restriction comes from the original denominator before you cancel. So domain restriction, what can't x be? Can't be 3/2. And that is my final answer. Now, just to sort of add on to this, if we were talking about graphing these functions, that 2x minus 3, that would be a hole in the graph because it canceled, right? I'd have a hole at x equals 3/2. This would be a vertical asymptote at negative 4/3. Agreed? I just lied. You shouldn't agree with me. This is not a vertical asymptote. Would this be? An x-intercept or a 0, right? Are there any vertical asymptotes? No, because the denominator canceled out. Are there any horizontal asymptotes? No, because the numerator degree was greater than the denominator degree. Okay, so go ahead and try these next two. Don't forget your domain restriction. All right, so we're multiplying. This is the same as f of x times g of x. And in my parentheses, I'm going to have x plus 2 butted up against x squared minus 4. This is truly just a foiling problem, isn't it? So some people want to factor this down, but guys, you understand, if I factor this, and it does, that I just have to put more back together. So I'm going to leave this alone. I'm going to FOIL. And if I go in true FOIL order, I would get x to the third and negative 4x, a positive 2x squared, and a negative 8. So put it in standard form. F times g of x should equal x to the third plus 2x squared minus 4x minus 8. Good? Okay, then we're going to do division. And anytime I have division, if I still have a variable in the denominator, that would mean that I definitely have to consider a domain restriction. So my numerator is x plus 2. My denominator is x squared minus 4. Here's where I need you to be careful. Maybe I asked for g of x over f of x, so please be careful. This does factor x plus 2, x minus 2. And with that in mind, we agree that that cancels. So what is my final answer in function notation? Well, if you wrote down x minus 2, you would be wrong, because where is the x minus 2? And the denominator. So what should be in my numerator? 1. Okay. So did you have that? Be careful with that. Now, what's my domain restriction? Back to before you canceled, x cannot be negative 2 or positive 2. Okay, so let's just think about this real quick. If I was graphing this function, would I have any holes? Yes, I'd have a hole at x equals negative 2 because that canceled out, right? Okay, now look at this. Would I have any zeros? Because this is the simplified one. Any zeros? No, because there's no way the numerator is going to equal 0. Any vertical asymptotes? Yes, at x equals 2 because that's what's left. So your domain restriction is either going to create a hole or a vertical asymptote mixed match. And then my last question is there a horizontal asymptote? I would not take 0. I would take it as y equals 0. And why does y equal 0? Because the numerator degree is 0, the denominator degree is 1. Or you start with the degree of 1 and 2. When the numerator is less than the denominator, it's y equals 0.